Okay, all right. Recording has begun.
So
Yes,
I don't have the answers to my homework because I'm on my mother's laptop. I broke mine.
you broke your laptop, you broke your mom.
I think I broke
I'm just
both
kidding.
of them.
Okay, all right. But hope you recall at least from memory. Oh, by the way, talking of breaking, there's one other girl in our batch who broke something. Yeah, Navia, you want to share how you're recovering from your broken ankle?
I'm in a cast right now, so it's getting better.
Okay. And then like even at workplace, a couple of injuries like that as well. So everywhere I'm hearing people with broken ankles. Okay, all right. Take care, guys. All right, so I'm sharing screen. So first I wanted to cover that confusion that we had last time on, so there are, let's say there are 3 sets. Okay, first let's start with 2 sets. Okay, so A and B, and thanks to Navia for raising this. It turned out that I was wrong, but I think Navia was also wrong for a different reason. But it doesn't matter. Okay, so let's go through what is the correct approach. So let's say there are 2 sets. The number of elements, sharing screen, right? You're able to see my whiteboard, right? All of you? Yeah. Drishit, please, video on, please. I should not have to tell you guys by now.
So I'm outside. I'll just turn it on in some time.
How long?
So like 5-10 minutes.
Okay. All right. Going forward, I need to hear from the parents, guys. If some video is going to be off or if the homework is not done. For example, I heard from one of the students' dad that the school exams were going on, homeworks could not be done. So I want some discipline, all right? You're doing it for yourself, but okay, anyway. All right, so if you have A and B, the number of elements in A union B, I'm not, technically you should put like this, number of elements is put as N of A union B, but just for simplicity, I'll just say A union B, okay? Just to avoid a lot of writing, a lot of N, okay? So this is number of elements in A plus number of elements in B minus number of elements in the intersection. That we understand, right? Because let's say, let's call this number as P, this number as Q, and this number as R, the common one. Okay, maybe I'll just give the common number as some other, let's say C for common, right? So we are looking for P plus Q plus C. That's your A union B. And what is A? A is your P plus C. What is my B? My B is Q plus C. And therefore, when I add both of them, I get P plus Q plus 2C, which is why I want to subtract this C, right? To give P plus Q plus C. That's how this formula comes, right? Now, same thing can be extended. Actually, even in this, let's stick with this, right? Suppose it's A union B, it's A plus B minus A intersection B. But suppose the question is number of cases where it's only exactly one of A or B, but not both. Okay, but not both. I mean, it's understood when I say exactly, it means it's not both, but just to be explicit, but not both. Exactly one of A and B. Exactly one of either A or B, but not both. So the desired answer is what? The desired answer is P plus Q, right? It's only A or only B, but not both. Okay. Now, how can we manipulate the numbers at our disposal are the full A, which is P plus C, the full B, which is Q plus C, and what is common, which is C, right? So using these, how do we manipulate? We can write this as P plus C plus Q plus C. I mean, I don't need brackets, I'm just putting it, minus 2C. So in other words, the number of elements in only A or only B would be A plus B minus 2 times A intersection B. Note that here it's only 1 time intersection of A intersection B. Here it's 2 times A intersection B. Okay. Now the same logic can be applied for 3 also. I'll pause here for a second. All of you good on this one? You were missing last class, right? Did you watch the recording? Are you caught up?
Yeah, sir, I understood.
Understood, right? Good.
Yeah.
Okay, Aditya, Sanvi, all good, right? Okay, cool. Now, suppose it's 3 elements, 3 sets. We can do the same thing. So let's do that. A, B, and C. Okay, so this is A, this is B, and this is C. Okay, so let me give names to these regions. I'll call the only A region as A, the only B as B, the only C as C. Okay, and the region that's common between A and B, but not here. So P, and then let's say Q and so I want to name it symmetrically, right? So I want to put A and B, right? Or rather the one opposite to A, which is common between B and C, I'll put like this P, right? Going in alphabetical order. The one opposite to B, which means it's A and B, but not in C. Sorry, A and C, but not in B, which is this. And symmetrically, this is R, let's say. And let's say this common region is some other third letter, which is neutral. Let's say X or something. Okay. Now, how do we arrive at, okay, so what is A union B union C? A union B union C is literally the sum of all of them. It's A plus B plus C plus P plus Q plus R plus X, right? That's what we suppose we want this. How do we generate? Using the known quantities. What are the known quantities? We know A. A is A plus Q plus R plus X. We know B. B is B plus R plus P plus X. I'm writing it symmetric, P, Q, R, therefore cyclically. So C is the small c plus P plus Q plus X. Okay. Now, so to achieve A union B union C, which is this result, obviously the first natural step would be to add everything. So when I add all of them, I get A plus B plus C, which is good. And I get 2 times P plus 2 times Q plus 2 times R, which is not so good. And then I have 3 times X, which is also not so good. Okay. Now, suppose I want this. What should I do? I should subtract. Okay. So I also know some intersection quantities. What are those intersection quantities? I know A intersection B. So A intersection. I know A intersection B is the common region between A and X, which is R plus X. B intersection C is P plus R, is it? P plus X. And then A intersection C is your Q plus X. Okay. So I add all of them, I get this. Now I can subtract. If I add all of them, what do I get? If I add all of these, I get P plus Q plus R plus 3X. Okay. Now, if I subtract this quantity, from this, right? So if I subtract minus of this P plus Q plus R plus 3X, which is the double combinations, A, B, BC, and CA. Then I get A plus B plus C plus 1P plus 1Q plus 1R, right? Which is almost what I want. Okay. But the 3X gets completely cancelled. I don't want that to get cancelled. And therefore, I'll add back just one more quantity, which is A intersection B intersection C, which is my X. So I'll add back that X. So I'll add, here I'm subtracting. And then I'll add back what that quantity is, which is, yes, which is X. Yeah, go ahead.
Why would you add X again?
Because this 3X and this 3X got cancelled. But I want in my final, this is my final goal. Remember, this is my final goal, right? My final goal is A union B union C.
Oh, okay.
Okay. So I'm deriving how we got A union B union C, right? So to summarize, what did we say? So A union B union C is nothing but we did A union B union C. So we said we first added A, B, and C, but that was too much excessive. And therefore, we subtracted the combination of A intersection B plus B intersection C plus C intersection A. So this combination we subtracted. But then we overcompensated by removing the 3X completely. And therefore, I'll just put back that one single X, which is this. That's how we get the A union B union C formula.
Got
Doesn't
it.
make sense, Yuvam? Okay, cool. Now, the other problem, so this was all good in the previous problem, in the previous class when we were discussing. Then I made a variant of the question. I said only one of A or B or C, correct? That was the problem I posed. So what is the what is it? This is how you can derive it for anything, right? You can have a simple diagram like this, and you can put what your desired result is. So what is my desired result? It's only A or only B or only C, but one of them. Sorry. So what I want is literally only A, which is just A, or only B, which is just B, or only C, which is just C. Okay, so let me do the same approach and see how can. So this is my goal. This is my new goal. How do I arrive at this new goal? In fact, I'll give you some time. So can you guys arrive at this value using combinations of A, B, C, A, B, B, C, C, A, and A, B, C? So using manipulating all of this, arrive at a formula for only one of A or B or C. Can you do that for me, please? No? Is this question clear to everyone? All of you clear on this, right? Okay. I'll make this narrow so that you have the full page here. And I'll also, can I erase this so that it doesn't, I'll erase all of this so that it doesn't, you have the recording anyway, so you can go through it. So you must construct this final result. The final goal is what I have at the bottom, using several of these, right? A intersection B intersection C, which is just X. Okay, and then you have each of them. So you have 6 quantities. Sorry, 7 quantities. The individual ones, the pairwise ones, and the triplet. So you have to mix and match all of these. Right? And then finally, you have to do some manipulation and arrive here. Right? I've laid it out nicely for you guys. Now it's up to you. Okay, Drishit, are you back at your desk?
Sir, I got the answer.
Okay, call out please, Yuvam.
Sir, it's capital A plus capital B plus capital C
Mhm.
minus small q
Small q.
minus small r minus small p.
But how do I get small q and small r and small p? That's a problem, right? I don't have access to small q or small r or small p. I only have access to these quantities here, right? I know what A is, I know what B is, I know what C is. I know A intersection B, which is R plus X. So
Yeah.
how do you generate Q plus R plus P separately? You understand the challenge, Yuvam?
Can you repeat once?
Okay, so it's like you're building. So these are the blocks available to you. What are the blocks available to you? You have only, so you have A, you know what A is, which is a collection of 4 quantities. You know what B is, which is a collection of few quantities. Let's say these are numbers. Let's say I put some number 60, 48, 72, something. And then you know the pairwise combination. Let's say this is 16, this is 20, This is 24, something. I'm randomly making up some numbers. But how do you cannot extract R, P, and Q separately. Are you following? You have access to R plus X together, P plus X together, Q plus X together. Similarly, A plus Q plus
Oh,
R plus X
no.
together.
So I was like trying to like simplify it. I did together only. I'll repeat. So it's capital A plus capital B plus capital C minus Q plus X minus R plus X minus P plus X.
Okay, which is A intersection B plus B intersection C plus C intersection A. That okay, all right. So if I do that, then what do I get? Just 1 second. Someone is at the door. I'll have to pick it up. Okay, no one is there. Okay, sorry guys. So please continue, Yuvam. Okay. So if I do the subtraction, then where do I land up?
You get A plus B plus C.
Do I?
You get small a plus small b plus small c.
But is it? So when I add A plus B plus C together, I get how much? I get A plus B plus C plus P plus Q plus R. Actually, two of them. So I get twice of them, right?
Yeah, 2b plus 2 plus.
Okay, and then I get 3x. And then you're asking me to subtract this quantity. And what is this quantity? This quantity is P plus Q plus R plus 3x. If I subtract, I don't get my desired result. My desired goal is this, no?
Oh, so maybe
Say that again, Yuvam. You're breaking up for me. I think some problem on your side. Arab, are you able to hear me? Yeah, some problem on your side. Yuvam, whenever you're back, we can continue debating this. Okay, any other answers, guys? Navya? Arav? Arya? Yeah, Arya, go ahead.
I so I got A plus B plus C, and then it minus 2 times A intersection B, B intersection C, A intersection C.
Okay,
Then
so
I did
you're putting 2 times here. Okay, so now
Yeah.
what? Yes, then continue, please.
so now you get minus 3 A plus B plus C, small a plus B plus C, minus 3x, and then you do 3 times A intersection B intersection C.
Exactly, right? So basically we need to subtract 2 times P plus Q plus R to compensate for this, but then you end up subtracting 6x instead of 3x, and therefore the 0x. So right now we have plus 3x and minus 6x. Therefore, we pack another plus 3x, right? So to summarize, it's this quantity and then plus. So minus 2 times this, plus 3 times A intersection B intersection C. Is this clear to everyone? Navya, is it clear to you? Okay.
So I
So
had a question.
yes, go ahead, please, Aditya.
So you have to find the value of either one circle, right?
Either one circle, meaning?
Like when it says you have to find a value of A, you have to find the value of the circle, right?
Yeah. Think of all of these as numbers. So the number of elements that appear in only A or only B or only C. So let's say there are 3 subjects. People take this subject, that subject, all of that. So suppose the question is the number of students who take exactly one subject.
Okay.
For that, you should do this.
Okay. Yes.
And what is the total number of students who are taking at least one subject? So that will be the first one, right? Which is A union B union C. I want to do the differentiation between the complete union versus exactly one.
Got it.
Okay, and you got disconnected in between, but my point is you have to subtract twice. If you just subtract once, the P plus Q plus R does not get eliminated fully.
Yeah, got it.
Okay, makes sense? Yeah, your line went blank for a bit. Okay, all right, cool. So let's continue where we left off from last class. So I think the first homework here is that. Is that homework? Homework 10, right? Veer, you're all good?
Yes, sir.
All okay, right? Okay.
Yeah.
So we were in question. We did Joe and Blair, and we did the Throkans problem. We did the 2013 problem. Okay, yeah, question 7. Non-decreasing sequence, 2 non-decreasing sequence. Okay. Veer, did you get something on this one?
I'll just open the document.
Okay. Meanwhile, I'll just go to someone else who's ready. Sanvi, you said you broke your laptop. Okay, anyone else? Arav, do you have an answer on this one?
So just 1 second. I also have to.
Okay, all right. All of you guys have everything handy, yeah? Please, before class. You know we are going to discuss this. Okay, I'll move on to someone else. Navya, you have an answer on this one?
I got C.
C, 104. Okay. Meanwhile, you guys have pulled up something?
Yes, sir. I also got C.
You also got
104.
C, 104. Okay. Cool. Anyone else? Arav or Veer?
So I got 104. Oh yes, sir. I got C as well.
Yeah, 104C. Okay. All right, let's discuss. That's good. If 3 people got same, it should be very likely. Okay. So 2 non-decreasing. Non-decreasing means what? It can be constant. So for example, the sequence 7, 8, 8, 8, 9, 12, 12 is non-decreasing, right? So it's not decreasing, but there could be periods of time where it's flat. Okay. So 2 non-decreasing sequence of non-negative integers have different first terms. Okay, so maybe the first one begins with A and B, have different first terms. And the second one begins with C and D, let's say. Okay. Sorry, first 2 terms. I mean, this is a sequence 1, this is a sequence 1, and this is sequence 2, S1 and S2. Okay, each sequence has the property that each term beginning with the third is the sum of the previous 2 terms. So the third term would be A plus B. Fourth term would be what? A plus 2B. Right? Sum of this and this. And then the next term would be 2A plus 3B, like a Fibonacci. And the next one would be 3A plus 5B. The next one would be 5A plus 8B. I think this is the 7th term, right? 1, 2, 3, 4, 5, 6, 7. Okay. So the 7th term is 5A plus 8B. And similarly, this guy would be 5C plus 8D. Okay. So he says each sequence has a property, blah, 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 different first terms, which means A is not equal to C. So A is not equal to C. Okay. And the 7th term of each sequence is N. So the 7th term matches, which means we have these 2 quantities matching. So 5A plus 8B. So meanwhile, we know that it's non-decreasing, which means A is less than or equal to B. And we also know that C is less than or equal to D. That's what non-decreasing. It could be a flat constant also, but C is less than or equal to D. So we have the 7th term should match. So which means 5A plus 8B must match my 5C plus 8D. Okay. So let's take everything to one side. I mean, a couple of terms to the side. So 5 times A minus C equal to 8 times D minus B. Okay. Now, obviously, both A minus C and D minus B have the same signage, right? So which means A minus C is positive and D minus B is positive, or both are negative. Doesn't matter. So we can just assume between the 2 sequences, we can start with some assumption, right? Let's say A is bigger than C because A is given to be not equal to C. So I will say A is bigger than C. Doesn't matter. So I'll say A is bigger than C this way. So if A is bigger than C, that means what? A minus C is positive. So on the right hand side, we must require D is greater than B. Right? D is greater than B. Okay. And then, so the sequence goes, A is greater than C, and then D is greater than B, right? So A is the smallest, right? In this case, A is and then A and C, D and B. Okay, so if I have to write it in ascending order, B is here, D is here, A is here, and then C is here. Okay, so C is less than A is less than or equal to B because they're starting terms, and D is bigger than B. Okay, so in sequence it's like this. So first C, then A, then B, then D. Okay, in what I have written, you might have done something different, but in what I have written, that's how it is, right? So now if this product has to match this product, 5 and 8 do not have any common factors, and we know A minus C cannot be 0 because A is different from C. So therefore, the first possibility that we want to try is this quantity being 8 and this quantity D minus B being 5, right? So 8 times 5 will match 5 times 8. Okay, so we can start with this, right? So which means D minus B has to be, this gap has to be 5, this gap has to be 5, and then this gap has to be how much? 8. And we can minimize this gap to be as small as possible. We can keep this gap as 0 because A is less than or equal to B. Okay, so let's start with the smallest possible non-negative integers. Non-negative means what? 0 is included, right? So I can assign 0 for C, and then after a gap of 8, A can be 8, B can be 8, and after a gap of 5, D can be 13. So this combination will work, right? Hopefully it'll work. We can just check, right? 0, 8, 8, and 13, which means the first sequence is all 8, 8. The first two letters are 8 and 8, right? So the last one would be 5A plus 8B, which is 13, because A and B are both same. 13 into 8, which is 104. Yeah. And let's just double check. Do we get the same thing for 5C plus 8D? So C is 0. So 0 plus 8 times 13, which is 104 as well. Yeah. Makes sense, right? Okay. All right. All of you good on this one? Makes sense? You did something like this only? Okay. I'll ask another question. What is the highest possible value of n less than 1000? Highest possible n that is less than 1000. Can you guys try this one, please? I don't know. I'm also thinking whether it's a doable problem or think about it for a second, guys. I'll also think. I don't think it's such a good problem. I don't think there's a direct way for this. Please ignore, guys. Please ignore. Sorry. Okay. I thought it would be a good problem, but no, it doesn't turn out to be. Okay. Ditch it. Next one. 7. That was 7th question, right? Okay. Next one. All of you understood this, right? Completely 104. Whoever did not get it. Okay. I know, Sanvi, you didn't have your notes, but you recall getting 104 on the previous one?
Yeah.
You recall getting that. Okay, cool. You're okay? Okay. Positive.
Actually, got
Yes.
disconnected. So I'll rewatch the recording.
Okay. All right, please do. Yeah, I didn't notice. Okay. Question 8. Positive integer n is nice if there is a positive integer m with exactly 4 positive divisors, including 1 and m, such that the sum of the 4 divisors is equal to n. So the statement is a little long, but okay. So n is the integer that we are talking about it being nice or not. So it's nice as long as there is a positive integer m with 4 positive divisors, sum of the divisors equal to n. Okay, and I'm just reading the same question again. Okay, no point. How many numbers in the set are nice? Okay, any idea? Did you guys do this one? Okay, so who's connecting back again? Drishit, you're back at home? Okay, good. So I don't know whether you paid attention to the previous one. Maybe you got disconnected. You can watch the video. We are
Yes.
just starting question 8. Were you able to attempt this one?
No, so my exam just ended. So
Okay.
I start doing everything now.
Okay. Anyone with this one? Arya, I know you had exams. You didn't have time to do it. But Arab, did you? Okay, or even at least partial progress. How did you guys approach Navya? How did you approach this? Any comments on any of these numbers, n or m, anything?
I didn't really do this. I didn't
Okay,
get her.
okay. Forget about everything else. Can you guys tell me which are the numbers? Let's focus on m. Okay, forget n. Okay, positive integer m with exactly 4 positive divisors. What will be numbers which will have exactly 4 divisors?
Four.
4.
Four
4
is
has 4 has 1, 2, and 4. It has only 3 divisors, right?
all right. Yeah.
6.
6. Okay. So, okay, all right. You're giving an example. 1, 2, 3, and 6. It has 4 divisors.
Eight.
8, 1. What are the 8? What are the multiple? 1, 2,
4, 8.
4, and 8. Okay.
10.
10. Okay. The 1, 2, 5, and 10. Okay. Okay. What is the pattern? What is the pattern?
No, but like if you go to the next digit, 12, it ruins the pattern.
Okay. Think about prime factorization, guys. When will there be 4 factors for a number m? If m has
So
4
14 or
yeah, again, you're giving me examples. I'm fine with examples. What is it? What will be the property of a number which will have?
It's 1, 2, and the number itself, and then half the number.
Does it have to have 1, 2? Okay, after 14, which will be the next number? Since you're finding a pattern. After 14, one more.
sir, after 14 it will be, it can't be 16 because it's a square number, so it will be 18.
What about 15? 1, 3, 5, 15. So that eliminates Drishit's logic that 2 has to be there, right?
Yeah.
Correct. 15.
Yeah. So someone's hand went up briefly, I thought maybe.
Sir,
Okay.
wait, I think I've a logic. If you prime factorize all of these, you get is it that paired digits will come and non-paired digits won't come?
Meaning?
Wait, so let me just confirm. I'm checking something.
So I'm not even looking at this problem. All I'm looking at, comment on number m, which has exactly 4 positive divisors. What would be typical m? So what will be the property of such an m?
So excluding like squares, cubes, and like raised to fours, etc. I think it'll be like excluding one and the number itself. Both the divisors will be prime.
Excluding squares, cubes, and all that, right?
Yeah.
So for example, let's take a number which is 30. It's not a square, it's not a cube. Okay, but it does not have 4 factors. It has a lot more, right? Or any number, for example, let's say we know like 72 is not a square or a cube. We know it has.
The digits must be prime, like the divisors must be prime.
Okay, meaning?
Like for example, if you take 15,
Yeah.
3 are prime excluding 1 and 15.
Okay, so yes, so formulate it better. Yeah, you're almost there, but repeat what you said once more properly, Navya.
Basically excluding 1 and the number itself. The other 2 digits must be prime in order for n to have 4 divisors.
Correct. Yeah. So yes, you're right. Arab, you
But
wanted to share something?
4 is not a prime.
Yeah, but that's because it's a square.
It's a square.
right.
Okay.
Yeah.
Yes, Arab, you were saying something?
So I'm not sure if this is relevant, but this is just a note which I noticed. So if the first numbers are, so say it's since there are 4 numbers, the first one's always 1.
Yeah.
And if you multiply the second and third one, you get the fourth one.
Correct. Correct. Which is also what
So if
Navya's more or less. Yeah. Go ahead.
So if you say the sum of it, so it'll be 1 plus x, if I let x be the second number, plus y, plus x plus y.
Or x into y, you mean?
Yeah, x into y, sorry.
I'm not even talking about the sum of those factors. So what is the number m which has 4 positive divisors? I'm not even adding them, right? So yes, so back to what Navya, everyone's saying the same thing. So let's say I have 2 power a times 3 power b times 5 power c times 7 power d and all that. The number of factors would be, we know it's a plus 1 times b plus 1 times c plus 1 times d plus 1 and so on, right? If this number has to be 4, literally there's only one possibility. You have a couple of them appearing twice, right? So which means the rest of them should be 1. For example, it could be 2 for, right? And so on, right? And everything else is 1, which means there's one prime factor with a power of 1 and another prime factor with a power of 1. And it has no other prime factors at all, which is why the number of factors would be this. Or you have one prime factor with a power of 3, right? Sorry, someone is saying something. Okay, so m should be the product of 2 distinct, so p not equal to q. Okay, in fact, let me say p less than q. Okay, or rather p not equal to q. Fine, p less than q is fine. Okay, or m could be p cubed, right? So one example that we saw for p cubed was 8. It has only 2 as the only prime factor, but it's 2 power 3. And several examples like 15, 3 times 5, right? So the 4 factors, back to what I think Ara was telling, are 1, p, q, and pq. Okay. Now come back to this question. A positive integer n is nice if there is a positive integer m with exactly 4 positive divisors such that the sum of the 4 divisors equal to n. So I'll remove all these other clutter. Okay. So m is the number so m is the number which has all of these factors. M has these 4 factors. Okay, m, and the m, which is, what is that m? It's literally pq. So this is the m, right? M is just a product of 4 factors, right? Sorry, m is just product of 2 distinct primes, or p cubed. Okay, so let's keep that also, right? So it's 1 p square and p cubed. So this could be m as well, right? So this could be m, right? Then also it has 4 factors. Okay, let's take both the cases. First, forget the cube wala. Let's consider the base case. Let's consider the the other case where there are two distinct factors, P and Q. Okay, now N is nice if the sum of the four divisors equal to N, right? Which means N should be the sum of 1 plus P plus Q plus PQ. Okay, and we can factorize this nicely, right? It's 1 plus P plus Q times 1 plus P. So it's in other words, P plus 1 times Q plus 1. So N should be a prime plus 1 times another prime plus 1. Okay, and we have only 10 numbers here, right? From 2010 to 2019, we'll have to see how many of these N's will satisfy this property. Okay, so I'll just take this case first, case 1. Okay, and then we'll come back to this case 2 where it's Q's, okay, later. Okay, so first I'll pause here for a second. So is this clear? What is M, what is N, and what are we trying to achieve? Everyone clear? You okay on this one? Aditya, you're okay? We are searching for an N in these 10 numbers from 2010 to 2019, such that it's the product of one number more than two distinct primes, or rather P plus 1 times Q plus 1, P and Q are primes. Okay, now how do we break this down further? Okay, so we can again have two cases, right? So either I said P is less than Q. I said P is less than Q just for simplicity. So we can have P equal to Q, P equal to 2, or P is not equal to 2, right? If P equal to 2, then P is odd, sorry. Okay, so if P equal to 2, then P plus 1 is odd, which is P plus 1 is 3. So it becomes, N becomes P plus 1, which is 3, times Q plus 1, which is even. Correct? Okay, so it means N is 3 times an even number, which means N is a multiple of 6. N is a multiple of 6. Okay, are you guys with me so far? Because
I don't understand how you derived 3.
Because I've taken this branch where P is 2. I'm keeping that as a special case because P is the only, 2 is the only even prime, right? So either the case where P and Q are both odd, which is what the vast general odd numbers or prime numbers are, or the special case where P alone is 2, right? And Q is, so if I take P alone is 2, then P plus 1 is 3, right?
Yeah.
Okay, so and then N becomes 3 times some even number because Q is odd, Q is prime. Both P and Q are prime. P is 2 and Q is some other odd prime. Let's say Q is 17, right? Something. So Q plus 1 is an even number.
Yeah.
So the product is definitely a multiple of 6. Now, in this section, what are the multiples of 6? In fact, 2010, straight away we can say it's multiple of 3. 2 plus 1 is 3. And then it's even. So it's a multiple of 6 for sure. So 2010 is a multiple of 6. The next one in the group is 2016. These are the only two multiples of 6 in this case. In this, okay. Now, if this has to satisfy, then what is this? This is 3 into, how much is this? 3 6 are, how much is the 18? 670. 3 into 670, right? So this 3 is nothing but P plus 1, where P being 2. And is 669 prime? Is 669 prime? Clearly not. Therefore, we can rule out 2010 from this way. 2010 is ruled out. Maybe from another way 2010 is possible, but from this way it's ruled out. Do you guys agree? Okay, everyone with me? Yuvam, you're with me?
So
Yuvam is frozen again. Yeah, go ahead. Go ahead, Yuvam.
prime number.
Hello.
So can you hear me?
Yeah, I can hear you now. Go ahead.
So I'm saying that why didn't you take 2 as a prime number instead of 3?
Why did I didn't understand your question. Why did I not take 2?
Yeah.
Why did I not take 2? I took 2. I said there are 2 branches here, right? P plus 1 times Q plus 1. I want to look at how this number would be. Is an even number or odd number, whatever, right? So I want to give special case for P being 2 because 2 is the only even prime,
Got it.
right? So if P is 2, then this is 3 times an even number, which means it's a multiple of 6. And then in the multiples of 6, there are only 2 numbers in this set of 10 numbers, right? And if it's 2010, I checked that 669 is not prime, and therefore this combination will not work for 2010. Okay, now will it work for 2016? Let's see, what is this? This is 3 into 672. So which is 2 plus 1 into 671 plus 1. Is 671 prime? Clearly not, because you can see 6 plus 1 is 7. So multiple of 11. So this is also not working out. So P plus 1 times Q plus 1, right, is not working out for the 2 possible numbers that it could have worked out in this range. Only these 2 had a chance. Rest did not even have a chance because the rest of the numbers are not even multiples of 6. Are you guys completely with me? Don't lose the plot, guys. All of you okay? Arya, all okay? Drishit? Yeah? Okay. Now, let's come to the other branch, right? So, which is P and Q are both odd. So, if P and Q are both odd, that means what? You get an even number times an even number, right? So, P plus 1 is an even number. Q plus 1 is also an even number, right? Because both P and Q are odd primes. So, which means this, this n that we are seeking is a multiple of 4. Multiple of 4. Okay. So, multiple of 4. So, which are the multiples of 4? So, the multiples of 4 in this range, 2010 is not a multiple of 4. The last 2 digits have to be divisible by 4. So, 2012 and 2016 and 2020 is not included, right? Yeah, 2020 is not even included. So, only these 2 stand a chance. And even now, it's not guaranteed, but at least these guys have a chance, right? So, which means, are you guys with me? Okay. Okay. Now, we are saying, so P and Q are P and Q are what? Prime numbers, right? P and Q are prime numbers. Now, what can be the ending digits of prime numbers? Ending digits of prime numbers can be either 1, 3, 5, 7, or 9. Correct? These are the ending digits for the prime numbers. Right? Why am I doing ending digits? You'll just understand in just a second. Right? If the ending digit of either P or Q is 9, then you have 9 plus 1, which is 10. So which means the number will end in 0. Neither of these 2 numbers is ending in 0. Okay. So when we are looking for prime numbers, we don't have to look for prime numbers that are ending in 9 at all. Because if either P or Q is ending in 9, then plus 1 would become 0, and therefore the product will be ending in 0. And the 2 numbers that we have narrowed down is not ending in 0. Okay. Ending in 5. If it's ending in 5, it cannot even be prime, right? 15, 25, 35, and all that, they're not prime. The only exception is the 5 itself. Can one of the prime numbers be 5 itself? Because 5 is the only prime ending in 5, which is prime. Everything else is multiple of 5, right? Therefore, it cannot be prime, right? So if let's say one of them is 5 plus 1, which is 6. So that means again back to this quantity is 6 times. So let's say one of them is 5 plus 1, right? So it's 5 plus 1. Let's say P is 5 plus 1. And can Q be something such that this product is one of these, right? We know 2012 is not even a multiple of 6. We saw 2010 was a multiple of 6. 2016 was the multiple of 6. So the possibility is 2016 work out in this case. Are you with me? Okay. So if it's 6 times, what will it be? 6 times 6 3s are 18. 6 3s are 18 again. 6 times 336, I think, right? 3s are 18, 21, 3s are 18. Yeah, 336, which means Q has to be 335, which is not prime, right? Therefore, we can conclude that the prime numbers that we are seeking cannot end in 5 either. So they have to end in either 1, 3, or 7. I'll again pause here for a second. So obviously, this is a difficult question, but if you think through all of these, like I said, right, some of these steps will come in handy for an easier problem, which is why I want you to go through this fully. I'll pause here. Sanvi, have I lost you, or you're completely with me so far?
Completely with you so far.
Excellent, excellent. If only I can see your full face, though. I can always see your head tangential. Same with Aditya also slightly. Turn your monitor a bit, Aditya. And now it's better. Sanvi, still not better. Want to see your full face. Okay, better, but okay. All right, fine. Okay, all okay. Everyone okay? Yuvam, you're okay? Okay, watch the recording, guys. If it's something is hazy, when you go for a second pass, it'll definitely be clear. Okay, so please watch. So let's go with the flow for now. So what did we conclude? We concluded that the prime numbers P and Q can neither end in 9 nor end in 5. Therefore, we have only 1, 3, and 7 as the ending digits of the two prime numbers. 1, 3, and 7. Okay, all right. If the ending digits are 1, 3, and 7, okay. Now, how do I generate 2012? So which means these are the ending digits. Ending digits of P or Q. Okay, which means end digit of P plus 1 or Q plus 1 would be what? One more than these, right? So they'll be either 2 or 4 or 8. Okay, now I want combinations of these, which will give me 2012 or 2016. How can I achieve 2012? Anything ending in 2 is possible only if I have a combination of a 4 and an 8. Right? A number ending in 4 multiplied by number ending in 8 will give me 2012. Right? So let's see whether that works. So the first one I can try is, right, so which means P plus 1 I can keep as 3 plus 1, which is 4. Okay, so 4 times what number will give this? So 4 times what will give this? So 4503, I think, right? 503. So it's not ending in 8, but it's ending in 3, because there's no guarantee, right? Just because 4 times 3 could also be ending in 12, right? Just like 4 times 8 ends in 12. So that is not working out, right? So let's try. So this is not working out. Let's try something else. So ending in 4 times ending in 8. So I can try 13 plus 1, which is 14. 14 times something. Does it work? So 14 ones are 14, 61. 14 fives are 56, right? And 62, right? So it's not even a multiple. Okay, so let's keep going. 24. 23 plus 1 is 24. So actually we should go, we should cover 8 also, right? So we should cover 7 plus 1, 8 times something, right? How am I going? So I tried 3 plus 1 times something. It didn't work. Next, I should try 7 plus 1 times something, right? Because I want to go in order, right? Ending in 4 or ending in 8. So the smaller number could be, the smaller prime number could be 7. So 8 times what? Is 2012 a multiple of 8? No. 2000 is a multiple of 8. 2012 therefore is not a multiple of 8. Therefore, I don't have to check. Next, I go for 13 plus 1. That also did not work. 14 was not a factor. Okay, so I'll eliminate this. I'll keep trying. Next one is 17 plus 1. 17 plus 1 would be 18. Would 18 go in this one? Let's see. It's not even divisible by 3. Therefore, I don't have to check 17 plus 1. That won't work. It might seem laborious, but it is, right? This, unfortunately, it is, right? Now you can see 23 plus 1, right? If it's 24, again, 24 is a multiple of 3. Again, when I'm describing all this is very elaborate and slow. But if you guys are in the groove, right, immediately if it's 24, it's not divisible. Therefore, I can move on, right? Next one is 27. 27 is not even prime. So 27 plus 1, I don't have to try. 33 plus 1, I don't have to try because 33 is not even prime. I'm looking for ending in this. Now 38, right? I'll keep going like this. 37 plus 1 is 38. Is 38 divisible? Not. It's not. How far should I go? I should go till I'm able to find a factor. If there are 2 factors for 2012, one of them has to be less than the square root of that. The other one has to be bigger than the square root of that, right? So approximately the square root of 2000 is 45. 2025 is 45 square. So I only have to check for prime numbers till 45, which is not too much. I'm almost there. So 38, I can check. It's not a multiple, right? 38 times 5 is 190. The balance is 12, which won't be divisible. So 38 is also ruled out. The next one is 43, and then I should be done with that, right? So 43 is what? 44 times something. And 44 is multiple of 11. 2012 is not a multiple of 11. So you can use simple tricks like this. We don't have to do elaborate division. 44 is multiple of 11, but 2012 is not a multiple of 11. So no point even checking. So I'm pretty much done because the square root of 45 square is 2025. I've checked all the prime numbers till 43, right? And this is not working. So I can conclude confidently that 2012 is not possible at all. Okay. Now let's try 2016. Is 2016 possible? So for it to end in 2016, we can have a combination of, so from this, we can have a combination of 2 and 8, or we can have a combination of 4 and 4. Yeah, 2 and 8 or 4 and 4. This ends in 6. This is, I'm talking about P plus 1 and Q plus 1, right? P plus 1 and Q plus 1 could end in 2 and 8 or 4 and 4 respectively. And there are different numbers. So one could be 13 and 23, for example. So a product of 14 and 24 in such a case. Okay, so let's analyze. So again, we have to back to business. So first of all, one observation that it's divisible by 9. In fact, 6 plus 1 plus 2 is divisible by 9. And it's divisible by 2 also. So it's divisible by 18, right? So just so that we can bear in mind, right? Now, let's try for the first one. So the first one ending in, the first prime number ending in 2 or 8 would be 8, right? 7 plus 1 is 8. Okay, so 2 times 8 and 4 times 4, right? So let's try 8 times what? 8 times what will give 2016? So 8 times 8 2s are, how much is this, guys? 8 2s are 16, 40, 8 5s are 40, 2. Okay, 252, right? So which is 251 plus 1. And is 251 prime? Yeah, looks like it. If you know your tables well, you would have encountered 251 by now if it's not prime. I don't recall 251 coming in any of the tables, right? If you're not sure, we can just quickly check. We only have to check till square root of 251, which is approximately 16. So clearly we can see that 3, 5 and all are ruled out. So 7 is no. 7 3s are 21, no. 11 would be the next one. Clearly 2 plus 1 is not matching with 5. 13 is the last one we have to check. 260 is a multiple of 13. Therefore, 251 is not a multiple. Therefore, 251 is a prime number.
So,
and 7 is also prime number. Therefore, 2016 works. Yes, go ahead, Yuvam.
so instead of checking if it's a prime number, you can just see if 51 is a prime number. That means it's not, it is a prime number because 51 is a prime number.
I didn't understand. 51 is, first of all, not prime. 51 is divisible by 3.
No, like, oh, okay.
But even if 51 is prime or not prime, what does that make 251? How does that help judging whether 251 is prime or not?
Because there won't be any digits ending in that number, right?
I'm not clear. So said we only have to check if 51 is prime. How does judging whether 51 is prime help us in judging whether 251 is prime?
I thought that there won't be digits ending in that, prime digits ending in that number.
I'm not following you. For example, we have 43, which is prime. 343, which is a multiple of 7 power 3. We have 243, which is 3 power 5. There are numerous examples where just because the last 2 digits are something, we cannot conclude anything, right?
Okay.
Or why even go that far, right? 4 plus 3 is 7. I can always make a multiple of 3 by putting something more here, right? I can put 5 here. 5 plus 4 plus 3 becomes a multiple of 3. Yeah, Yuvam, make sense?
Yeah, got it.
Okay, all right. So what did we conclude at the end? That we should not lose the plot, right? So 7 and 251 right, are the two prime numbers. So our M in this example would be 1, 7. P and Q would be 7 and 251. And this will be 251 times 7. So we have a number M, which is 7 times 251, whatever that product is. How much does that be? 17. I don't need to know what that number is. 25 times 7 is 175. So 1750 plus 7, 1757. So 1757 is a number which has exactly 4 devices: 1, 7, 251, and 1757. Okay, and the sum of all of them is adding up to 2016 because of the fact that it is nothing but 1 plus 7 plus 251 plus 251 times 7, and both 7 and 251 are prime. Right. So at the end of all of this, we have concluded that it's for 2016, we have found one combination where it works. And we have not found anything else. In fact, for 2016 itself, in the other branch, we did not find anything. 2010 also, we did not find anything. 2012 also, we did not find anything. So we are okay with 2016. The only other case we have to do is it possible that M is 1 plus P square plus P cubed? Right? Because if M is P cubed, then it'll be this, right? So if this is the case, then the sum would be 1 plus P square plus P cubed, right? So how can I simplify that? 1 plus P square plus P cube. So that's nothing but 1 plus P times 1 plus P square, right? So this is a little tricky one, but essentially we have to see whether there's a perfect cube. Okay, we can roughly see that the cubes are all fairly distant, right? So if you write out all the cubes, they are spread apart. They get spread apart quite a bit, right? So in fact, let's write out all the. So this is 1. What am I writing? The cubes, right? So 1, 8, 27, 64, 125, 216, 343, 720. What is it? 512 for 8. 512 for 8 cube. 9 cube would be 729. Okay. So first of all, we don't have to search for this, right? We can start straight away with big numbers because we need P cube plus P square plus P plus 1. So we need big numbers if they have to fall in the 2000 regime, right? So we can straight away start with big numbers. We know that 11 cubed is 1331. So if you add the 120 and the 11 and all that, we are not going to reach anywhere close to 2000. So we can start with 12 cubed. 12 cubed is Ramanujam number, right? 1728. Okay, so to this, if we add 12 square, which is 144, and add another 12 and add another 1, we'll still be well short of 2000. We don't have to do this sum. We'll be well short of 2000. On the other hand, 13 cubed will well exceed 2000, right? Will be much more than 2000. We can just do a quick. So 13 square is 169. So if we do 170 times 13, right? This is far exceeding this thing, right? This is 21. How much is this? This is already going to be, what am I doing? I'm not multiplying properly. 17 times 13 is how much, guys? 221, right? Yeah, 221. Okay, so 221. So it will be in the 2200s. If you add 13 cube plus 13 square, it will become even bigger. So it was too short for 12 cube. It was too big for 13 cube. Therefore, we straight away eliminate this other possibility. It was straightforward to eliminate. So at the end of it, we found only one number, which is 2016. Potentially 3 numbers could have worked out, either 2010 or 2016 in this branch, or these two. The other numbers did not even have a chance. They could not even have worked out, right? And among these, we saw in each branch which actually works out and which does not. Yeah, definitely a long problem, but it's a very good learning. I thought it's a very good problem, right? You learn a lot of things in this. If you really understand what's happening, you learn a lot of things about prime factorization. Very good classic number theory question. Is this clear, guys? At least for superficially, is it clear, or you're terribly lost? Please be honest, guys. It's okay. Drishit, I'll put you on the spot because I know you for long now. You're okay?
So yeah, but then I was confused about like what about the ones larger than the square?
Larger than the square meaning?
Like you said that you have to count only till the square, right?
Till the square root.
Square
Right?
root,
Till the
sorry,
square
yeah,
root.
the square
Yeah,
root.
yeah.
So then what if there are many more after the square root?
If I found, so this goes back to forget this problem. For any number, if I group them as pairwise factors, one of the factors will be less than or equal to the square root, right? So even if it's let's say a big number, 1000, like I'll just make some number like 19600, okay, which is 140 square, right? So it's a fairly big number, but if I start clubbing them as like this, right, this column will end at 140. One of the factors has to be smaller than the square root, right?
Yeah.
The smaller factor, whenever you're grouping them pairwise, has to be less than or equal to square root. So which means if I keep searching for 2012, what pairs will give the product of what pairs will give this, it's enough for me to search till I've reached whatever 45 or something.
Right.
Right?
Okay.
I don't care about the other pair, the other number. The Jodi might be a big number, right? But the smaller one I would have definitely encountered before this.
Yeah. Understood.
Okay. All right, cool. Navya, you're okay on this one? Understood this fully?
Yeah, so
Cool. Nice. Okay. Yeah, I knew this problem will take a long time. It's fine. Let's see. 20. Okay. All right. Question 9. Veer, you understood this one fully? The question 8 that we just discussed.
So I understood up to the part about where you got the cubes, and then I didn't understand past there. I think I got lost somewhere.
Which cube? The two cases, 1p, p square, p cube, that one? Or
Yes. No. I'm saying the part where you started doing trials and trial and error for these different cubes.
oh, okay. Which is the very last part alone you did not understand.
Yes,
Okay.
exactly.
That's fine. So all I'm saying is, if at all it has to be sum of 1 plus p square plus p cubed, we can straight away start, because as numbers get bigger, the cubes will also get spaced apart quite a bit. So we can start away. Let's say p is, I know 10 is not prime, but I'm just saying, suppose if we start with 10, 1000 plus 100 plus 10 plus 1 is far less than 2000, because I'm looking at numbers which are adding up to 2000 range, right? So the next one is 11. So 11, I know 11 cubed is 133, which is why I keep insisting you guys should know perfect squares, perfect cubes and all that. If I even with 11, when I add these, this is maximum going to be in the 1500 range. I can go to 12. 12, of course, I can straight away skip because it's not even prime. But even then, 1728 is 12 cubed, 144, 12 and 1. I don't have to add. Just upper say I can see that this is going to be falling short of 2000. And if I go to 13, the 13 cubed is going to well exceed 2000. And if you further add 169 and 13 and 1, it will far exceed 2000. This is a very narrow stretch here, right? So we can be safe that we are clear.
Right. Okay, got it. Thank you.
Yeah. But the hard part was the other one, right? This p plus 1 and q plus 1 and splitting all of those cases. I'm glad you understood that part well. Okay, nice. Cool. So this one, number 2013 is expressed as blah, 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 some factorials by another set of factorials. What is minimum of, what is mod of a1 minus, a1 plus b1 should be as small as possible. Okay, why does it say a1 plus b1 should be as small as possible? For example, I can have a case where a1 is a number like 2013 itself, right? And then a2, a3 all the way till am match b1, b2 all the way till bn, right? So for example, I can have big numbers, right? Let's say a2 is 983, right? And then b1 is also 983, all right? I'm just saying 983, some random number. So A1 plus B1 could be a very big number, right? And let's say all of these cancel off perfectly, except there's an additional 201. I'm sorry, guys, I'm not explaining it well. Okay. Okay. So if this has to be 2013, A1 can be 2013. Okay. And B1 can be 2012. Okay. And then the rest of these numbers can match perfectly. Let's say these numbers match perfectly and get cancelled off. And this cancellation will result 2012 factorial will get cancelled, leaving 2012. This is one set of values for A1, A2, A3, B1, B2, B3, where it will work. But A1 plus B1 will become huge, right? 2013 plus 2012 will become huge number. He wants to minimize A1 plus B1 to be as small as possible. Okay. Okay, I'll stop here. Anyone, Sanvi, were you able to do this one? Or how did he approach?
I don't remember how I did this sum
Okay, all right.
because I saw the new homework too, right? So
Okay,
I think I forgot how I did this
all right,
one.
sounds good. That's fine. Aditya, how about you?
So I didn't see that as small as possible. So I took A1 as 2013 and B1 as 2012. And I got 1 as the answer.
I see. Okay. Okay, that's fine. It's try. Arya. Arya, you didn't try, I guess, right? Arav, what about you?
Samitra, I couldn't do the homework. Actually, I moved to Hong Kong this week.
Okay. Okay, that's fine. So let's. Anyone else, guys? Anyone else did something?
Sir, I have a question what you did. So
Yeah.
why would you take A1 as 2013 and B1 as 2012?
Because A1 factorial will almost cancel with B1 factorial, leaving just 2013, right? So what is 17 factorial by 16 factorial? Isn't it just 17?
Yeah.
Because 17 factorial is 17 times 16 factorial.
Yeah, correct.
Right? So exactly same logic. Yeah.
Oh, okay.
Okay. So the first order of business is let's try and do some prime factorization here, right? So how much is 2013? 2013 is 3 times 3 6 are 18, 3 7s are 3 1s are. Okay. And you can clearly see that 671 is a multiple of 11, right? 6 plus 1 is 7. We just did a previous problem in similar lines. So this is 11 and this is 61. Okay. So 2013 is 61 times 3. Okay. So if this is the product that we want, 61 times 11 times 3, right? So one example could be, let's say this A1 was 61 factorial and the corresponding B1 was 60 factorial. Okay. So that will cancel off. A2 could be likewise for me to get 11 and I can have 11 factorial upper and 10 factorial niche. So this could be 11 factorial. There could be other numbers also in between, but this could be 11 factorial and 10 factorial, cancelling off this. And similarly, 3 factorial here with 2 factorial here. And these are just, this is my A1 and B1. And this could be some, let's say A10 and B13. I don't even need them to be exactly the same numbers matching. And this could be A7 matching with B24 or something, because it doesn't say what M and N are, some numbers, right? And I can have the rest of it cancel perfectly, perfect cancellation. Let's say I can have repeat numbers for a niche and they all cancel off. So ultimately what remains is just 61 times 11 times 3, right? In this case, A1 plus B1 would be 61 plus 60, which is 121. and the difference would be A1 minus B1 would be like 1. But this goes back to what the mistake Aditi also did, right? So is this the smallest possible? Can I achieve something even better? Now 60, so 61 is prime. So the only way I can get 61 is having 61 itself. But 60 is not prime, right? I can generate 60 through other ways. If I have a prime number, the only way to generate the prime number is having itself. But 60 is not prime. 60 is a product of several primes. So can I generate 60 some other way? As in, can I have some cancellations upper, right? Which will make my 60 go away. So like I said, 61 at the top, I don't have a choice because 61 is prime. So I have to keep 61. Now, is there a way for me? Okay, so I'll try. So suppose 59 factorial here in the bottom. 59 is also prime. So for me to cancel off 59, I need a 59 upper also, because 59 is prime, right? So I need a 59 in the numerator also. 59 and 59 will cancel, leaving 61 and 60 balance. But can that 60 cancel off with something else? This 60 does not need to be explicitly there as 60 factorial. So I can have 60 as what? 5 times, let's say 12 times 5 or something, doesn't matter, right? So 12 times 5, right? 12 times 5 is 60, right? So now I can introduce a cancellation such that the 12 is taken care of and the 5 is also taken care of. How do I do that? I can have upper, I want to have a 12 factorial, and niche I want to have sorry, I want to have, okay, I want to simulate a 12 and a 5. Okay, so sorry guys, let me just illustrate this again. So I want to have a 12 and a 5, which is a 60, so that this 60 will cancel off with the 61 factorial. Sorry guys, I'm not at all explaining clearly. One sec, let me just start all over again. Okay, so this 61 factorial, 11 factorial, and 3 factorial. So I have the 11 factorial and the 10 factorial will cancel to give me 11, which is perfect, right? And the 3 factorial and 2 factorial is cancelling off, which will give me 3. That's also fine. I want the result to be 61 factorial, right? Yeah, 61 factorial upon 60 factorial. Okay, so 61 factorial upon 60 factorial. But can I replace? So nothing changes with the 11 factorial and 10 factorial. I'll just leave them as it is. Nothing changes. So can I, all of them are factorials, right? So can I replace the 60 with some other combinations with factorials cancelling off? As in 60 times 59 factorial. So 59 factorial ho gaya. Can I achieve 60 through a cancellation of factorials? That's the question, right? So yes, I can do that by replacing 60 with, let's say, 12 and a 5, right? I'll replace with the 12 and a 5. Now, how do I achieve a 12? I can achieve a 12 by putting a 12 factorial in the denominator and 11 factorial in the numerator. I can have 2 11 factorials in the numerator, right? Because the numbers are all greater than or equal to. Okay. Similarly, I can achieve a 5 by putting a 5 factorial in the numerator, in the denominator here, and a 4 factorial in the numerator. Okay. Now I'll lay it out all clearly, and then you'll see, right? So my upper wala numerator is going to be like this. So 61 factorial. 61 factorial. Oh my God, my 1 and 61 factorial times 11 factorial times another 11 factorial times 4 factorial times 3 factorial. Okay, upon my denominator is 59 factorial times 12 factorial times 10 factorial times 5 factorial times 2 factorial. Okay, I've literally written it down. Now let's see how things combine, right? So this 11 and 10 was cancelling off to give me my 11, right? So that was this combination. So that is intact. Okay, a 3 and 2 was giving me a 3. So that is also intact. Now, this 4 and 5 was intentionally buried this way so that I can get a 5 in the denominator. Okay, effectively, this will cancel off to give me a 5. And this 11 and 12 was buried so that I can get a 12. And this 12 and 5 is effectively like a 60. So I have, so effectively I have, this is my 11, this is my 3, and this is my 61 effectively, right? So this, if I combine the 12 and 5 and put it here as 60, then it cancels off to give me 61. So I have my 61, I have my 11, I have my 3, I have my product, 2013. Is this clear, guys? Yeah? Cool. Yeah, it's all about prime factorization, guys. If you know your prime factorization well, you'll know how to manipulate things. So I'm sure you'll get better as you try. Okay, so that was question 9. How are we doing with time? Okay.
So what's the answer?
So yeah, so 61 and 59. And sorry, I didn't finish it, right? So yes, therefore answer is 2. We cannot go below 59. Why can't we go below 59? Because 59 is prime. 60 was not prime. Therefore, we could break it into 5 and 12 and plant things for cancellation. But 59 is prime. I cannot break it down. Right? I cannot avoid 59 in the denominator to cancel off with the 59 in
And
the
so
numerator.
it's not like necessary to take 12 and 5. You can take like 20 and 3 and then you
Correct. I can take 10 and 6, 20 and 3, doesn't matter. Or doesn't have to take 2 numbers. I can take 2 into 2 into 3 into 5 and make each of them cancel. So I can generate 60 multiple ways and accordingly put successive numbers in the numerator and denominator so that things cancel out.
Okay, got it.
Right? Manipulation.
So I don't get why you can't go under 59.
Okay. So why could we split 60 into 5 and 12? Because 60 is not prime. Correct?
Yeah.
59 is prime. So I don't want 59 in the numerator after all the cancellations because I know 2013 ka prime factorization is 61 into 11 into 3. It does not have a 59 in it, which means the 59 in the numerator coming from the 61 factorial should cancel off with another 59 in the denominator. And the only way I can get a 59 in the denominator is by having 59 factorial. I cannot generate 59 any other way. But 60 was not the case. I could generate a 60 using combination of other numbers, smaller numbers. Does it make sense?
Yeah.
Okay, so that was question 9. I think question 10 seems fairly easy only, right? How many 3-digit numbers are not divisible by 5, have digits that sum to less than 20, and have the first digit equal to the third digit? Should be a fairly easy question, right? Yuvam, what did you get on this one?
Sir, I couldn't do this one.
Okay, any answers? Anyone, guys?
So I got B.
B, 60. Okay.
I
Navya,
got D.
D. Okay. Any other answers?
So I got B 60.
Okay, so a couple of you 60, one of you D. Okay, let's see.
7.
Yeah.
I wrote 11. Yeah, I wrote 10 B only. I got B.
You got B as well. Okay, so all of you got B only. Okay, so yeah, seems like a simple problem, right? Not divisible by 5, digits sum to less than 20 and have the first digit equal to third digit, which means it's a number like A, B, A, right? And the sum of the digits is less than 20 and then A is not equal to 5. A is not equal to 5 or 0. Okay, so we can just loop through, right? How many numbers? Not divisible by 5, have digit less than 20. Okay, so if first of all, if A is 1, right? 1 plus B plus 1 will not even, yeah, okay. So 1B 1, any combination of B will work from B being 0 to 9. So there are 10 numbers like this. If it's A is 2, 2 plus 2 is 4. So again, any combination will work. Likewise, I think we can keep going, right? 3, 4, until 5 you're safe, right? 3, 4, 5, we're all safe, right? Because 5 plus 5 is 10. And B can be anything from 0, 1, 2, all the way till 9. So we have 10. Oh, no, 5 is not there, right? A cannot be 5. So I have to glance because A cannot be 5. Okay, so 1, 2, 3, 4 are okay. And then from now onwards, it will start decreasing, right? So if A is 6, so 6 plus 6 is 12. So B can be only from 0, 1, 2, all the way till 7. So that's 8 numbers, I think. Okay, so B has only 8 choices. If I'm doing some mistake, please stop me, guys. Similarly, if if A is 7, 7 plus 7 is 14. So B can be 0, 1, 2, so until 5. So which is 6 numbers. And you can see, right? You can see the pattern. It decreases by 2 because I'm increasing by 1. And there are 2 digits, right? So this will be 4 numbers. And then if it's 9 and 9, right? B can be only 2 numbers, namely 0 and 1. So which is 2 numbers. And then the answer should be the sum of all of them. So how many are there here? 10, 10, 10, and 10. Okay, this 10 is not there. So 40, 40, and then some of these, right? Which is, am I doing some mistake, guys? I'm okay. 60, right? 60, yeah. Okay, fairly straightforward. After all that we went through, this is nothing, right? All right. Do we have time for one more? We're just on time. Let's see. Yeah, the last one is also fairly easy, guys. This is nothing. I just must be one of the easier questions on the paper. Which of these is a perfect square? Drishit?
So I didn't do the thing.
Okay.
Like,
Yeah. So they're all successive factorials, right? So if one of the factorials cancels off with the 2, and then, right? So for example, so I should get a factorial times another factorial times another number, which is a perfect square. So here, I think that's happening, right? So 17 factorial into 18 factorial is 17 factorial into 18, right? So I have the perfect square coming here and the perfect square coming here as well. 18 by 2 is also a perfect square. Okay, so this works. Just simple trial and error will just give you this, right? So essentially, you need the divide by 2 for the higher number to give a perfect square. So 18 is the only one when divide by 2 gives a perfect square among these numbers. Yeah, fairly easy, right? Okay, all right. Did we finish this homework fully then? That means? Okay, nice. So we finished discussing this homework and then we have the entire other homework, right? Which is the one that Sanvi, you said you did, but you didn't do the rest of these questions, right, Sanvi?
I did these questions. I just done them like 2 weeks ago, so I don't remember what I'd written. I don't have my laptop
Yeah.
right now.
Okay, that's fine. This is the problem of doing homeworks promptly. We should delay them till discussion.
Yes, sir. I will do my homework late next time.
All right, I'm just kidding. Yeah, please bring your workings, guys, so that the class discussion can be fruitful. Always have your working so that you can compare what you did versus what's discussed. Okay, all right. Hope it was useful. Yeah, that one problem was brutal, I know, but go through it a few times, guys. I'm sure it'll become easier, right? Bottom line, know your prime numbers, know your prime factorization well. That concept is very, very important, right? Understand, don't just mug up the concept. Okay, cool. Chalo, bye.